about 19 years now at this stage. So I've been through a few bits and pieces over the years. So I'm going to go through the compliance induction here for you right now. So I've got a slide deck. And I'll go through the various different bits of it. And please feel free to stop and ask questions at any time. There's no problem at all. And if you have any questions, like say when you're on site, you can look me up and ask me anything. There's no problem at all. So I'm just going to share my screen there now, and I'll just make sure that I am sharing. So can you see my screen there now?
Yeah. Guys, can I just ask for everyone except for Stephen, can you just pop yourselves on mute because there is a lot of background noise there if you don't mind. Yeah, okay. I think that's better. Perfect, thanks.
Perfect, and obviously if you want to ask questions, there's no problem. You can take yourself off mute and ask a question away. Can you still see my screen there? You can. You should see something about transforming lives.
Yeah.
Yeah.
Yeah, perfect.
I can only see GS. I can't see any slides.
You see what? Sorry.
Just your initials. I can't see your actual screen.
I think in the bottom corner. In the bottom corner of your screen, you might see a small little icon with the presentation there. Maybe if you click on that instead.
Or guys, if you just try and switch off your cameras for me, because again, it's just slight delay with the sharing. And just see, does this work?
No, still the same.
Okay, Jamie, would you mind just logging back out and logging back in for me?
Yeah, no bother.
I'm just conscious that, a lot of people can see it and then there's some that can't. Is it just Jamie or is there other people? Susan, are you able to see it?
I'm not able to see it as well.
Yeah, I can see it.
Okay. Nikki, would you just even try similar to Jamie, just logging off and logging back on?
Yeah, sure, we'll do that now. Yeah, thank you.
Perfect, thank you. Guys, apologies for this. Just with such a large group, it's very strange that some can and some can't see it.
Lauren, I noticed as well that when I put on the Teams app, because my partner is working from home in the house, if two people are using it, it seems to be putting a strain on it, and it could just be that as well at home. I think some of us are probably just strained, but the app seems to be working better than the website itself. Might help.
Okay, yeah. So if anyone does have the app on their computer, try that.
Yeah, and also maybe if you have your camera turned on, maybe turn that off as well, so that's taking a bit of the bandwidth as well. So
I'm able to see it now. Thank you.
Oh, perfect.
Yeah, that worked. That worked for me as well.
Brilliant.
Oh, fantastic, guys.
Good stuff.
My heart rate there was jumping up. Thanks, guys.
Great stuff. So we'll move on here. So and again, lads, feel free to stop and ask questions. No problem at all. So this is about compliance, GMP, and the customer. Okay, so what we're all about here in Boston Scientific is transforming lives. The products that we make here, every day, they help someone around the world. And also the products that we make here could help one of our own families well at some stage, and there have been employees here that their own family have benefited from our from our products as well. So I'll go through the presentation here. So what we go through is we go through the Boston Scientific quality policy. We'll talk about good manufacturing practice, so GMP, that's a buzzword in the medical device industry. Compliance and audits, traceability and recalls. Okay, so we'll start off with the quality policy here, right? So you see on top of the screen there, it's I improve the quality of patient care and all things Boston Scientific. So that's the corporate quality policy, and you see that written up around the corridors here in Cork. And if you go to any site in the corporation, in the States or wherever, you see that same quality policy written up over in the various different plants. So it's our guiding priority. So it's about hitting the bullseye every time, right? So we aim for patient care. So that's where we want to. Our focus is all about our patients. Every product that we make goes towards helping somebody out there somewhere. So it's our patients are key here, really. So we need to deliver quality products to those patients, to our customers every day, and the quality of every product has to be right, basically. So and outside that then is the quality and compliance. So we have our various different, procedures and policies and the culture here to make sure that our patients are they are delivered quality products at all times. And then we have our customer service outside that. So it's great having a quality product, but we need to deliver it to the hospitals, to our customers in time, have a good stock of products available for our customers to have at all times. And we also look at making sure we introduce new products on time and at the right quality here as well. So there's a big part of our team working on new products now at the moment. There's a whole stream of new products coming online, and they're all being brought into the right quality standards and getting the procedures right and validated correctly, just to make sure our patient is getting the right product at the end of the day. So it's all going towards the just making sure our patients are well taken care of. And then the outside of that again is the cost reduction. So that's to make sure we make everything as efficiently as possible, so then we can produce more products then to satisfy our customers. Any questions so far?
No.
Okay, great stuff. So what's GMP? So GMP, good manufacturing practices. So they're the practices required in order for us to conform to regulations that control the manufacture and sale of medical devices. So we have to comply with the various different regulations that are in place there to make sure all our products are safe and effective, and we're audited at periodic times to make sure that happens. So in terms of GMP, what that means is that the place here is clean and hygienic. Excuse me. So basically, if you walk into the plant here now, you see the place is very clean and tidy, or clean rooms are clean, and there's a good system in place in terms of keeping everything tidy and everything in its place. We have a controlled environment, so all our products are manufactured in clean rooms. So there's a very low level of dust, and the humidity is kept at the appropriate humidity, and the temperature is kept properly. So basically minimizing risk to our products. We've all got defined and controlled processes. We all have our procedures that we have to abide by, and that's all making sure that our patient gets the right product. Any changes have to be evaluated. So okay, we have our procedures, but we can change those if we see improvements in there. So there's a proper change control process that those procedures need to go through. We've clear procedures. So our procedures are clear and unambiguous. There's no question what's right or what's wrong. They're very, very clear of what has to be done. All our operators are trained on those procedures and the various different aspects of making the product. All the records of manufacture are kept. So every time we make a product, we sign off to say that a certain task is done. We sign off to say that a certain inspection is done. We sign off to say that we've used certain equipment. And we also have to make sure that we're trained before we even make the product. And then we have a system for recalls. So if we do have to bring a product back from the field, we have a system in place through traceability and all the various different procedures that we have corporate-wide to make sure that we pull back the right product if need be. So then just our little graphic then on the right. So we have GMP in the middle. So there's all the different things that feed into it. So we have our management commitment and continual improvement. So our management from the very, very top are all committed to making good products to deliver to our customers. We have a risk management process in place. So every product, every process has its own risks. So we have controls in place to mitigate against those risks. We have a quality management system. So to make sure that we have the right procedures set up in the first place and that they're audited on a regular basis to make sure everything is right. We have site and facilities management, as mentioned, about the controlled environment, and the whole area is kept clean and tidy and all the rest of it. We've product control, so we've various different inspections and checks and balances throughout our whole process to make sure we deliver the right product to our customer. And we have training and competency. So all our product builders are trained, all our support staff are trained, and we're all competent in what we do. So that's all, and it's all monitored throughout the whole process. So I'll move on. So basically, we use documented procedures to capture these good manufacturing practices. So whenever you're on site, you'll be trained up on all the procedures that you need to know, and that training will be documented as well. So that's the basis behind GMP. So also, so again, so the good manufacturing practices, it ensures that our products are manufactured to a quality appropriate for their intended use. So before I go on to compliance, any questions on GMP or good manufacturing practices?
No, it's all good.
Yeah,
Very good.
everything good.
Happy enough.
Great stuff, brilliant. We move on there, so to compliance. So compliance describes Boston Scientific's efforts to ensure that they are aware of and take steps to comply with relevant regulations. And compliance to the regulations of a particular market allows you to sell your product in that market. So compliance, right? So we have all these various different regulatory agencies that have their own rules and regulations that we have to comply to. So we make sure that our processes and our procedures are set up to be compliant to those regulations. And then those regulators, they send auditors in every so often just to make sure that our procedures are compliant and that we have evidence to prove that our procedures are compliant to the to those regulations. So compliance has, you see the little graphic there on the right. So we have our requirements, we have rules. There's all different standards that we have to abide by. Governance, so we're audited to those. So there's regulations. Transparency, so we have to be open about all our procedures and make them available to the auditors, so and our records to show them. And we have policies in place and procedures, and it's basically the law as well. So it's it's if you want to make medical devices and if you want to have your to sell product in certain markets, you have to buy all these rules, and it's the law to do that. So compliance to the regulations of a particular market allows you to sell your products in that market. So it may be a case that you might have approval to sell your product in one market and not the other. So that's kind of in the news now with the COVID vaccine. So it's like certain vaccines, you might have heard that the Pfizer vaccine was only approved in the States before it got approved in Europe. So the various different regulatory bodies in the different markets approve the products for those markets basically. So our medical devices, they're similar to it's a similar approval process to the COVID vaccine, although the COVID vaccine was fast tracked and all that, but we still abide by the same process basically to get our products approved. So compliance to our procedures is how we ensure that we're utilizing good manufacturing practices. So again, our procedures are in line with the regulations, and if we abide by those procedures, we're utilizing good manufacturing practice, and we can ship our product to the relevant markets. So then there's a kind of a hierarchy of our procedures. Okay, so it starts off with the global quality manual and the quality policy. So the global quality policy and the quality manual, that's a corporate-wide document that every site in Boston Scientific uses, and every site has to abide by those rules. And then it's also the level under that is all the global policies for the various different aspects of quality. So basically, all the sites have to abide by these policies basically. Then we have the lower level below that again are our SOPs, so they're our standard operating procedures. So again, they may vary from site to site, but there are we all have our standard operating procedures that we have to abide by. And then we're getting down to the nitty gritty, the actual work instructions. So they could be like a work instruction for an operator online to do a certain task. There could be an instruction for somebody in engineering to do a validation. There could be instructions for somebody in quality and how to do non-conformance. So they get into the detail of what actual work is to be done. And then the level below that again is forms, templates, and records. So you know, when you're completing certain work that's listed in the work instructions, you may have to fill out a form, you may have to fill out a template, and you may have to record what you've done. So they're all the lower level of records. And so basically any of these can be seen by an auditor. So we have our work instructions, and then the auditor might want to see evidence that work instruction being completed, done properly. So we'd show them the records and the completed forms that come from that work instruction, and then that's evidence then that if those forms and the templates and records are completed correctly, then we're evidence to show that we've done the right thing. Any questions on that? So, so I'll just go into the standard operating procedures. So what's covered in an SOP? So equipment and technique can be included in there, the location of manufacturer, any safety precautions, in-process controls, sampling, packaging, maintenance of equipment, storage. So an SOP can contain all of these things, including the actual detail of what is to be done at the particular station or whatever instruction you're working on. So any idea of anybody of what makes a good standard operating procedure? Anybody?
Has to be clear, concise.
Exactly. Precise, yeah, absolutely.
Clear instructions so that anyone can follow on the floor without any guidance, with some clear pictures would also be handy for the person who is using the procedure. Yeah, pretty much I would say, as far as it's clear instructions and easy to go, could make a good SOP.
Absolutely. You've said it all there. That's
step by step, sign off each step as you go along.
Exactly. That's it. So like all those things are absolutely perfect. And like photographs and diagrams are way better than any kind of words written down. So if you have a photograph of what you're supposed to be doing, that's key. Like it's like the message, a picture tells 1,000 words. So I think that's a phrase anyway, but any kind of a diagram or photograph or picture of what's going on is key, and the instructions have to be totally clear, totally unambiguous. There can't be any doubt of what the instruction is. So as you mentioned as well, do step-by-step sign off as you go. So we have a system here called MES, Manufacturing Execution System. So as we complete our steps on the procedure, we sign off on the MES system to say that we've done that particular task. So yeah, they're all excellent answers there. Perfect. Thanks a million. So documentation and records. So then when we as we're going through our procedures, we complete various different records, okay, and they're evidence that we've completed the procedure correctly. So, and these are what we show to auditors when they want to see evidence of something being done. So the records, they must be legible. They must be legible, not illegible. Legible, complete, permanent, accurate, and original. So they have to be totally clear. Just like the procedures, they have to be clear of what's written down. Must be complete. So all boxes must be. If we have to fill in certain information in certain lines or boxes on the form, they all have to be complete. Has to be permanent, so no pencils or anything like that, or no Tipex. You use a biro. They have to be accurate and original. And again, if we make a mistake, if we, as we all do, we need to cross out what we've written down and write in the correct thing above it and sign date it, and also put in a justification of why we're making that change. And again, electronic signatures are legally binding and are the equivalent of an individual's handwritten signature, and we're all accountable and responsible for all our actions initiated under our electronic signature. So I might have mentioned MES, so that's Manufacturing Execution System. So when we complete our tasks, on the line, our work instructions, we sign off electronically on our MES system to say that we've done that task. So that's an electronic signature, it's not a handwritten signature. So we all have our own, passwords. So don't tell that password to anybody. And by signing off, we're stating that we have done whatever task initiated under that signature, and that we're accountable and we're responsible for that. Okay, so any questions on documentation and records? All good. So how do we check for compliance? Okay, so we're checked for compliance through audits. Okay, so there's a couple of different types of audits. So there's internal audits. So that's a team of auditors from BSE, and those auditors check to make sure we comply with local and corporate procedures, and they're independent to the area being audited. So in Cork here, so we have a team of auditors that we audit each other's areas. So we don't audit our own area. So every area would get audited at least once in the year. So it's managed by the compliance team, but various different people from the different departments would be on the audit team, and we would audit not our own area, but some other area that we don't work in. So, and then we just go through the lines and we find anything that's we ensure compliance. We make sure that everything's working okay, and if there's something wrong, then we just highlight it and basically get it fixed. That's how the internal audits work. Then we also have external audits. So they're sent in by the regulatory authorities, and they determine whether we work to the appropriate standards. So as mentioned, there's various different rules and regulations from these regulatory bodies, and they come in and they make sure that we're operating to those standards. So they're impartial and they're unbiased. So they've nothing to do with Boston Scientific. So they're impartial, they're unbiased, they're independent, and they're very powerful. So in the very worst case, if they find that we're totally out of compliance to the procedures and the regulations, they can decide that they can tell us to stop making a certain product if it doesn't meet the right standards. So that's how powerful they are. Hasn't happened in Cork, thank God, but it has happened in other companies around the world. So it's key that we abide by our procedures and hit those regulations every single day that we're making our product. So then there's various different outcomes of audits. So there's poor results and positive results. So generally in Cork, over the years, we've been pretty good with audits. We have a great team here, and we do very, very well at audits, and we have a good compliant culture, and we want to keep that way. So by having good audit outcomes, we have satisfied customers, or we've open markets. So we whichever markets we can ship our products to, we can still ship to those markets after a good audit. We have a competitive advantage over any customers that have trouble with auditors. We have a good image and reputation, and we're compliant with the legal requirements. And also just on the image and reputation piece there as well. So like the various like we're also kind of competing against other Boston Scientific sites as well. And if the top people in the company are deciding where a new product goes to be manufactured, they might decide, oh, Cork's doing great. They've been doing great at audits over the last number of years. So okay, we'll give them the new products here. So it's actually very good that way as well. And like if we have good results at audits, it's a good image. We have all those things, like satisfied customers, but we also get more business as well from the corporation. Then on the other side, then right, if the bad audit outcome, we get dissatisfied customers, because if we're told to stop shipping a product, our customers won't get it. We've closed markets off because we can't ship that product to the market. We have a poor image and bad reputation, so we might not get our products. We mightn't get new products from the corporate when corporate decide of where new products go. The company could close. There could be legal and financial penalties, and worst case as well, imprisonment. So that can happen, and it has happened in various different companies. But not here in Cork anyway. So, and long may that last. So any questions on audits before we move on?
No.
Great stuff. So as I said, Cork has been very good with audits, over the years, and we have a great team here. So we're constantly working at keeping that audit outcome good. So then we have our quality checks. Okay, so our products are checked at various different points in the process. So when the raw material comes in the back door, there's a sample check at incoming quality control. When the product then gets to the production line, we have various different checks throughout the whole process to make sure that we're meeting certain standards as we go through the process. Then there's a check on the finished goods when we finish making the product. And so we're all basically responsible for the quality of our product, from incoming to right to the shipping out the back door. Everybody is responsible for the quality of the product. And it's assured through compliance with the quality system. So we have our quality system in place. We have our procedures set up to make sure that the quality of our product is kept all the way through. So and again, like these are like at the various different checks here. It's a sample that's checked. We don't want to check every single thing. So we're all basically responsible for doing everything right. So that's the process there. So again, so what's the takeaway from compliance and GMP? So by ensuring we're compliant to our procedures, we're hitting the bullseye and delivering quality products to our customers every day. So this protects the patient, the product, Boston Scientific, and ourselves, basically. So the aim is our patients. So every time we do anything here, every time we make a decision, we always have our patients in mind, because that patient could be one of our loved ones, So so we always have to keep our patients in mind at all times. Is that all okay, everybody?
Yep.
Perfect. So so traceability. Okay, so you'll hear this word very often here. So traceability is our ability to know what material has gone into each product. Every product that we make is made up of raw materials, and those raw materials have their own batch numbers that come in from our suppliers. So every finished good that we make, we know exactly which piece of raw material from which batch, from which supplier has gone into that product. So it's vital that we accurately document what batch of component was used in the manufacture of each individual product right back to our supplier. So again, our manufacturing execution system, MES, so when we're signing off to say that we've done a task, we also sign off to say that we've issued certain lots of raw materials into that batch as well. So these are the raw materials, these are the material that we actually use to make that product. So we know exactly where they came from. So we document accurately which lot of product is used in that finished good. And we also document, what equipment we've used to make that product. So if we have to weigh, a certain amount of a chemical on a weighing scales, we document the acid number of that weighing scales, and that ensures that weighing scales was calibrated properly. If we use a certain tool to make our products as well, we document the acid number of that tool as well, and then we know that tool has been through its correct preventive maintenance schedule. So we have all these controls in place to make sure that we use the right tools, we use the right material, and also as well, we will not be able to sign off on anything unless we're trained to do our task as well. So all our training records are loaded onto the system as well, so that so we can't do anything until we're fully trained. So, and it's basically it's a legal requirement that products can still be linked to facilities, shifts, and individuals years after manufacture. So, for example, we could make a product, and like the shelf life in that product could be 2 or 3 years, and after 3 years, the product could be used on somebody. So we need to trace back to 3 years before that to know what shift that was made on, who made that product, which piece of equipment made it, which clean room the product was made in. So we can trace back years after the product was actually made. We can trace back all these things. So again, if there was a complaint or a fault, we must investigate and report. So again, if our traceability is right and we found out and say in 5 years' time there's a complaint with one of our products, we can investigate that complaint, and we can trace back to all the equipment, material, people involved in making that product, so we can investigate what actually went wrong properly. So it could be down to a piece of equipment, a faulty piece of equipment, and we can trace back to that piece of equipment and investigate the issue basically. So how do we maintain traceability and line clearance? So the purpose is to line clearance. The purpose is to maintain segregation and physical separation of lots. Is to assure product integrity, to prevent batch mix-up, and it's the removal of all scrap and unnecessary components. So when you're working at a certain station on the line, and you're making a certain lot of a product, so you only have the components that you need to make that product. You only have the pieces of equipment specific to that product on the line, and you only have the instructions for making that product available to you on the line, and basically nothing else. And then when you move on to a different lot or a different product, you must remove all those components from the previous lot. You must remove all the equipment that was used on the previous lot. So anything associated with that previous lot must be removed before you even start commencing on the new lot. So that's line clearance basically. So you would clear the line out of all the old materials and equipment that were used, take them all away, and then you start your new lot with your new equipment, your new components, your new work instructions. So when is this completed? It's completed prior to commencing every batch, every single time. And who does it apply to? It's performed per batch and per person, and it applies to every single device across our plant. So anytime we change a batch or change our part, we basically remove everything associated with the previous product away from the station before we start work on the new product. So if that's done right every time, then there's very, very little chance of any mix-up that can go on. So here's an everyday example of line clearance that we use at home. Okay, so so basically you're cutting chicken at home, making the dinner, making the stir fry. So given the possible presence of bacteria on raw chicken, so consumers need to store and handle chicken appropriately. Okay, so basically you're chopping the chicken there on that chopping board. No, and then you go off and make your stir fry. No, you wouldn't come along afterwards and get your bread and cut the bread with that same chopping board and same knife. You wouldn't. You basically clear all that away, you wash it away, and then you get a either use the washed chopping board and knife afterwards, or use a different one. So that's a kind of example of of line clearance at home. So we basically use separate cutting boards and plates to produce meat, poultry, seafood, and eggs. Use one cutting board for fresh products and another for raw meat, poultry, or seafood. Wash thoroughly all plates, utensils, and cutting boards that touch raw meat, poultry, seafood, or eggs. So again, it's the same principle at at work here. We just clear out everything from the old lot before starting off on the new lot. Is that okay with everybody?
Yeah.
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 Perfect. So here's a typical workstation here. Okay, so you see the different. You see the two line clearance blocks. The red one on the left, line clearance end of lot, and the green one on the right, the line clearance start of lot. So everything that you're working on for that particular lot needs to be between those two line clearance blocks. So all your material, your lot that you're working on, all your equipment, everything has to be between those two line clearance blocks. So in order to maintain segregation, physical separation of lots, we need to remove all scrap unnecessary components of the previous lot before we start off on the next lot. And then we see that screen up in the top right there. So that's our manufacturing execution system, MES system. That's the screen that we work on. So we sign into there. So when we're starting off our work on that particular lot, we sign into that particular workstation on our MES screen using our password. We issue all the components that we're working on, and we sign off to say that the various different tasks are actually done, and we record any equipment that's been used. So you see a microscope at that station there. So we would record that particular microscope. That microscope has its own unique asset number, so we'd record that asset number on MES for the particular lot that we're working on there. And and you can see the area that's obviously in between lots. So we removed all the components and everything off that station before we start off on the new station, or on the new lot, I should say. Okay, so a recall. So what's a recall? It's a complaint or otherwise reported product defect may lead to the need for a recall. So I suppose the most common kind of recalls we hear about in the news are, recalls of cars. You might have heard of a certain brand of a car, the airbag might be working or something like that. So you'd bring your car back, you hear about it, you get a notification from the garage, you bring your car back to the garage and they fix the airbag and off you go again. So it's a similar thing in the medical device, although it wouldn't be heard about as much on the news. So it's basically any action taken to recall a product suspected or known to be defective or hazardous, and there should be prompt in accordance with a predetermined plan. So it has to be prompt because if there's a product out in the field that could harm somebody, we need to get it back as quick as possible before it does harm anybody. It's like an airbag not working in a car. The more cars that are out there with the airbags not working, the more people are going to get hurt. So we just want to get everything back in fix as soon as possible. And so Boston Scientific has procedures to deal with recalls. So if there is something like that, thank God they don't happen too often. But if they do happen, there is a predetermined plan that we kick into gear when that does happen. And these procedures are followed, and they should be specified in writing and made known to all who may be concerned. So again, if there is recall in Boston Scientific, it goes to the highest level. We all work as hard as we can to make sure that everything is brought back in time and fixed, and it's signed off then at the highest level in Boston Scientific. So again, traceability again is the key in determining the scope of the recall. So so that's why we all sign off to say that our work is done. We sign off to say that we use certain equipment, that we used certain materials in our products. So if there is an issue with a certain component, we can trace back then to that component, and we can trace back to which product used that component, so that determines the scope of the recall. And so if that traceability wasn't done properly, then the scope would be much bigger, and we would have to recall a lot more product than we would need to, compared to the traceability being done correctly. So the most common quality problem is actually packaging. So 53% of all recalls in the corporation or in the world, in the industry, are related to packaging. So you see there on that bit of text there at the top of the screen. So packaging issues is about 53%, and then other issues then are much less. So investigations in relation to recalls have led to jail sentences and thousands of euro worth of fines. So that happened in this PIP breast implant scandal. I think that was in France a number of years ago. So there was a lot of issues there in that company, and it did lead to jail sentences and lots of thousands of euros worth of fines. I think it was actually millions of euros worth of fines. So it's a very serious business. So just an example of a recall that we did have here a good few years ago. So we got a complaint for this product. The product is called an Extractor Pro device. It's basically a balloon. What this balloon does, it's for removing gallstones. So what happens is that the gallstones are basically broken up, and then this balloon goes beyond the gallstones. They find the various different the vessels that have the gallstone. The balloon is put down the vessel beyond the gallstone, then the balloon is blown up, and then the balloon is pulled back, and it takes all the bits with it and takes it out of the patient, so the patient doesn't have any more gallstones. So what happened in this case was that the complaint came back, and it said that there was 12 to 15 mil syringes were packed incorrectly with a lot instead of 9 to 12 mil syringes. So there's various different size balloons in that Extractor Pro product family. There's big balloons, small balloons, and then they're packed with the appropriate size syringe. So a bigger balloon would have a bigger syringe because it needs more air to blow up, or more saline, I should say, to blow up. And then a smaller balloon would have a smaller syringe. So what happened here was that this was a smaller balloon. It was a 9 to 12, and it was supposed to have a 9 to 12 mil syringe. So it was a small balloon, but it was supposed to have a small syringe, but instead it got packed with a bigger syringe. So what would happen there is that the doctor could take the big syringe and thinking that it's a small balloon, and try and inflate the balloon, thinking it's a small syringe. And basically with the bigger syringe, then you'd basically burst the balloon because it'd just be blown up too much because it's the bigger syringe. So that was the risk. So the root cause was confirmed to be a line clearance breakdown where the incorrect paperwork was scanned for the lot, and as a result, the incorrect syringes were packaged. So you might have seen in a previous slide, I might go back to there a second actually, just to show you. So you see those line clearance blocks, right? You see in the middle of them there's a little slot, and there's a little place to put a label at the side of it. So in there goes the actual lot number of the actual product you're working on. So in this case, because line clearance wasn't done properly, the wrong lot number was on the line clearance blocks, and they were working off the wrong lot basically, or they thought they were working off the wrong lot. So so basically the incorrect paperwork was scanned for this lot, and as a result, the incorrect syringes were being packed. So so the previous lot used a different type of syringe. So the paperwork for the previous lot was still at that station. The people scanned the paper from the old lot, and the wrong syringes got put in there. So here's an example of, or here's the actual complaint device that came back. So you see the label there says 9 to 12, but the actual syringe inside in the package then is 12 to 15. It might be hard to see there, but it is actually the bigger syringe that was put in there. So that what that did to the Cork site. So our patients and physicians actually found our errors. We didn't find our errors. It was our customers and our patients found that error. So the complaints that led to this recall were detected by the physicians during use of the device. Our site reputation, our quality reputation is key to ensuring the continued success of the Cork site. So our processes, we endeavour to mistake-proof our production processes where possible. However, the quality of our products depend on each individual to strive for right first time and to be consistently vigilant for errors, mistakes, or defects. So that's key. So that recall was basically caused by line clearance not being done correctly. If the line clearance was done correctly, that issue wouldn't have happened, and we wouldn't have had to go through all that recall process. And no, nobody got hurt doing this during this because of this issue. Thank God. It was just the one lot that was impacted, and that lot was brought back here to Cork. The physician found it during the use of devices, so there was no impact to the patient, thank God. But worst case, we could hurt somebody, and that's what we don't want here. And also in this case now, although no one got hurt because of it, which is great, but it did damage the reputation of the site an awful lot. And a lot of work was done then to fix the issue. So any questions on that?
No.
Very good. So I'm just going to finish up here now. So basically, just kind of just to get ourselves thinking, basically. So who's closest to our heart, right? So there's all these people here. So our mom, dad, brother, sister, son, daughter, newborn baby, partner, husband, wife, best friend, grandparents. So no, if this was usually during the induction, you'd all be in a room here, but because of COVID, we're doing this virtually. So in this case, now I would hold up two different, two devices. Basically two devices of the same product. I would hold up two of these, right, and I would just ask you to pick which one of these would you prefer to use on your mom, your dad, your son or daughter. The answer should be either of them, basically, because they're both made to the same standards. They're both inspected to the same procedures. They're both manufactured by trained people. So basically, every single product that we make is made to the same standard, and that is done by using the right procedures, they're using our right training, doing our line clearance properly, abiding by our procedures correctly, and making sure that we do the right thing every time. And if we do see an issue, we'd stick up our hand and say, lads, there's an issue here, we need to fix it. There's nobody going to give out to anybody for raising an issue. That's only going to improve things. So that's the key message here. So all our patients' lives are all in our hands. Just making sure that we're shipping the right product to our patients every single day. So that's all I have from compliance. Any questions, anybody? We're finished a little bit early.
No, thanks.
Happy enough, thanks.
Okay, great stuff out there. Great stuff.
Thank you.
Thanks.
No bother at all. So I'll just hand you back to Lauren. You there? So now I'll just I am Lauren there and see is. She's just gone offline a second.
Hi guys. So how are you finding it so far? Did anyone have any further technical issues?
No, all good.
No.
No.
All good.
No, everything good.
Perfect.
Brilliant. Yeah. Thanks a million, Stephen.
No bother at all. And again, if anybody has any questions, when you're on site, look me up and I'll